How many different repeating patterns can we make by arranging points in a plane so that every point is surrounded by an identical arrangement of points? An infinite array of such points in 2 dimensions is called a Bravais net. To illustrate these nets, I'm representing points as spheres, as shown here. A Bravais net can be described by 2 vectors, A and B. You are looking at the special case where A and B have the same length and are at 90 degrees to each other. We would call this a primitive square or primitive tetragonal net. The application of these vectors ensures that every point in the mesh is surrounded by an identical arrangement of points. Any point on the Bravais net can be reached from any other point by repeated action of A and B. An important concept is the idea of the unit mesh, represented here by a square. This is the smallest area that describes the overall symmetry of the net, and from which the net can be built by repetition. In this example, there is 1 point per unit mesh, and this is what we mean when we use the term primitive. You can replicate the unit mesh by pure translation and reproduce the entire net. We can define the unit mesh anywhere, however by convention the unit mesh is drawn by connecting adjacent points. Vectors A and B don't have to be the same length. If A and B have a different length but are still at 90 degrees to each other, we call this a primitive rectangular or orthorhombic net. And here is the corresponding unit mesh. If A and B have different lengths and the angle between them is not 90 degrees, we call this a primitive oblique or monoclinic net. Here, gamma denotes the angle between A and B. And here is the corresponding unit mesh. There are 2 more cases we need to consider. When A and B have the same length and the angle between them is exactly 120 degrees, we describe this as a hexagonal net. Although the simplest unit net is not a hexagon, it's easy to see how a hexagon can be constructed. When vectors A and B have the same length, but the angle between them is not 90 degrees, we could describe this as an oblique net, but this obscures the full symmetry of this particular net. We can alternatively draw vectors A and B at 90 degrees as shown here, with net points at the origin and in the center of the unit mesh. Now that our unit mesh contains more than 1 lattice point, it is no longer called primitive. Instead, we call this a centered rectangular net. In summary, there are 5 Bravais nets, 4 primitive and 1 centered, oblique or monoclinic, rectangular or orthorhombic, centered rectangular, centered orthorhombic, hexagonal, and square or tetragonal.